Okay, this is customer Jason Dayberry. We are going to perform clearancing on rotor 1 and film it, and then we're going to do the second rotor, and then after that we're going to lighten everything. So here we go. Clearancing rotor 1. Okay, Jason Dayberry, clearancing rotor number 2. Okay, so we're doing lightening, same customer, Jason Dayberry, rotor 1. We've already clearanced this rotor on both sides, and we've already lightened it on the first side. We're now going to lighten it on the second side. Okay, second rotor for lightening, Jason Dayberry, rotor 2. Here goes. Okay, so last modification for Jason Dayberry. He's decided he also wants to do the combustion chamber clearancing on the rotor. We've already done his clearancing and his lightening, and we're going to run this program now. Okay, so if we zoom in, you should be able to see now, maybe we can pull the light over, you'll see this entire area here around the combustion chamber has in fact been clearance. And that clearancing is for engines that are either going to be running high boost, high horsepower, high RPM, when there's enough load on the rotating assembly and the crankshaft where enough crankshaft deflection can actually cause this portion of the rotor to hit the center of the rotor housing between the spark plug holes, and that's where the furthest out portion of the rotor housing is and the furthest out that the rotor is, and the contact usually happens sort of right in here. So this is a gradual tapered clearance area that we do on all sides of both rotors. Okay, so Jason Dayberry's rotors, we have finished clearancing both sides. That's clearancing the face and the tips here, which is our race clearancing. And then we have also lightened both sides of each rotor. The next step is we are going to take these rotors over to the balancer, and we're going to film balancing the rotors on their own axis and then balancing the rotating assembly. We'll see you there. Okay, so we're going to do our first spin on Jason Dayberry's rotor number 1 and see where it leads us. Should get measuring right about now. So if we just look at the monitor, zoom in there, we'll see that we're counting down, and we should hit 0, and that's our readings. So it wants us to take off 4.9 grams on the left and 5.9 on the right. So we're going to mount this up on the mill and do some corrections. See you in a minute. Okay, so Jason Dayberry balancing. We've already spun this rotor up on the machine, and it's asking us to take off material on this corner and this corner. So we're just going to film the first correction we're going to make. Okay, so we're going to stop filming here, and then we're going to mount this on the machine and spin it again and see where we're at. So we've done our second rotor spin. We know we just have to take a minimal correction on this corner, so we're literally just going to turn this on, remove about 1 gram, and that's it. That's all there is to that one. We're going to spin it in a minute and see where we're at. So a final spin for Jason Dayberry's rotor number 1. Okay, so we're 0 on both sides. This rotor is done. We're going to finish the rotor 2 and then spin it up next. Okay, so we're going to spin rotor number 2 now. Okay, and rotor number 2 is also 0 on both sides. So these are done. We'll see you next when we're ready to spin up the rotating assembly. Okay, Jason Dayberry, rotating assembly balance and corrections. Take 1. Okay, so we got to do 6.1 on the back and about 6 grams on the front. We'll do corrections in a minute. Correcting Jason Dayberry's rear counterweight to about 6 grams. Should be good about there. Now we're going to move on and do the front. Front counterweight correction. Okay, all corrections are done on back and front counterweight. Jason Dayberry, final spin, see if we hit it. Okay, yeah, we hit it bang on the money. We're zeros on both sides. So both rotors have been brought to zero. Rotating assembly is zero. This rotating assembly is ready to box up and ship to the customer.